Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is find the maximum length of valid subsequence part 1. Now the problem category is of hard level, but I would say after watching this video and understanding the problem and the solution approach, you are going to find it very easy to solve. In the problem, the given input is an array of numbers. So we are given an array and they are of numbers. Basically the array contains numbers. The output we need to give is the length of the longest subsequence, and that longest subsequence should satisfy the below condition. We have a condition that this longest subsequence or this subsequence should satisfy, and the condition is that, let us say your subsequence is sub sub, then the subsequence you have sub, the zeroth index element and the first index element, when they are added and taken the mod with 2, will produce some value, right? Also, the subsequence first index element and second index element, when added and taken a mod with 2, will produce some value, right? You are going to continue this process for all the adjacent 2 elements, and it is going to continue for the last 2 elements as well in your subsequence of n-1 index and subsequence of nth index. So let us say you have n plus 1 elements in your subsequence, then the last 2 elements are going to have the index as n-1 and n, right? So we are going to say the n-1 index element in your subsequence, when added with nth index element in your subsequence and then taken a mod with 2, will produce some value. All these values produced by all these next 2 elements getting added and taken a mod with 2 should be equal. Now this might sound a bit confusing, so let me clarify this. Let me try to explain you the problem with some examples. So let us say the example number 1 is the given array is 1, 2, 3, 4. Now first of all, let me tell you what is a subsequence. If you are confused about the subsequence concept, it is basically selecting few or all elements of your given array in the same order in which they are in the array, from left to right. For example, if this is my array, then I can say 1, 2, 3. 1, 2, 3 is a subsequence because 1, 2, 3 are in the same order as they are in the original array. I can say 1, 2, 4 is also a subsequence because 1, 2, 4 is in the same order in my subsequence as they are in the array. 2, 4, 1 is not a valid subsequence because although 2 and 4 are in the same order, 1 is before 2, right? So 1 cannot come after 2 or after 4 because 1 is before 2 and 4 in the given array. So basically selecting few elements in the same order as they are given in the array. So now we know the concept of subsequence. Now we need to find a subsequence from this array, and that subsequence should be the longest subsequence, right? That can satisfy the below condition. The condition is that every two consecutive elements in the subsequence, when added and taken the mod with 2, will produce the same output. So let us try the brute force approach. Let us try all the subsequence. Let us say 1 is the part of my subsequence. If 1 is the part of my subsequence, then what is my second element? We don't know as of now, right? Let us try with 2. 2 is my second element. Okay, if 2 is my second element and now I have 2 elements in my subsequence, then I can apply this particular formula in my subsequence. I can say 1 plus 2 mod 2, this will be equal to 1, right? This will be 3. 3 mod 2 will be equal to 1. So for this particular data, the mod value, the current formula is giving the output as 1. So now the thing is, whatever subsequence you are about to create, for every 2 elements, sum then taking the mod with 2 should produce the output as 1, right? Now let's try with the next element. The next is 3. So it is 3 here. Now 2 plus 3 is 5. 5 mod 2 is equal to 1. So now it is valid as of now. It is fine because still the formula is producing the output as 1. It is fine. Now what about 4? Can we include 4 as well? Let us try. Alright, 4. 3 plus 4 is equal to 7. 7 mod 2 is equal to 1, right? So the formula is still valid because the output which it is producing is 1. All the output is 1. So this particular subsequence is the longest subsequence, right? It is having total 4 elements. So the output is going to be 4 because we need to find the length of the longest subsequence. Now let us take one more example. That's because in the first example we are actually selecting all the elements. Let us see when we will be required to skip few elements. Let us see that example. So let's say the elements are 1, 2, 1, 1, 2, 1, 2, right? In this case, let's start with 1. Let us say first element is 1, second element is 2. Okay. Now these are my 2 elements. Now in this case, you will notice that the output is 1. Basically, we need to apply this particular formula, right? That add the adjacent 2 elements, then take the mod with 2. So 2 plus 1 mod 2 is equal to 3 mod 2, which is equal to 1. So this is 1. Now we are bound that all the subsequence which we are about to produce or create, for all those subsequence, the adjacent 2 elements, when added and then taken the mod with 2, will produce the same output, and the output has to be 1, right? Okay, we can include this one. That's because if we include this one, this 2 plus 1 mod 2 will be equal to 1, right? 2 plus 1 will be 3. 3 mod 2 will be 1. Now, can we include this 1 as well? No, we cannot. And the reason is, if we include this 1, 1 plus 1 will be equal to 2. 2 mod 2 is equal to 0, right? So these two elements together in the subsequence will not be valid, right? So let us say we are not including this element. I am talking about this one. So what I can do, I can take this 2. Maybe we can try with this 2. And yes, this is going to be valid because 1 plus 2 is equal to 3. 3 mod 2 is equal to 1. So basically, what have we done as of now? 1, then 2, then this 1, then we have skipped this 1, then this 2, and then we are going to include the 1 and 2 as well. So we are going to include the 1 and 2 because this particular subsequence is going to be valid. All the adjacent two elements, when added and taken the mod with 2, is going to produce the same output. So as of now, I think the question is pretty clear. Now let us focus on the solution approach. And one thing I want to ask you guys when we are focusing on the solution approach is the formula. The formula is telling us a lot of things. The formula is telling us that two numbers are getting added and we are taking the mod with 2. This mod with 2 is telling a lot of things, and that is because, let me actually copy this formula and try to explain you in detail, because this formula is going to help us solve the entire problem. Let us say there are two numbers, 5 and 3, right? If I put these two numbers in my formula, the output is going to be 0, right? 5 plus 3, 5 plus 3 is 8, 8 mod 2 is equal to 0. If instead of 3, I have 4, so 5 plus 4 is going to be equal to 9, and 9 mod 2 is going to be equal to 1, right? The thing is, guys, whatever is the sum of this particular part, if you take the mod of any number with 2, the output can only be equal to 0 or can be 1. These are the only two possibilities we have, right? If we have just two possibilities, the problem is now to find the subsequence for which, when we apply this formula, all elements are either 0 or all elements are either 1, and we need to consider the length of that subsequence which is higher or which is the maximum. So now, if we are given an array, let us say we are given an array of, let us say, 10 elements, okay? Now the thing is, guys, since the subsequence can only have the output as 0 or 1, when we apply this particular formula for every two adjacent elements, then you need to understand that this particular formula is going to produce 0 or 1 for some specific use case. For example, if I have a subsequence, right? If I have a subsequence of all odd numbers, if I have all the odd numbers, for example, if the subsequence is 1, 3, 5, 7, 9, the thing is, if all are odd numbers, then in this case, the every two odd number, when added, let us say 1 plus 3 mod 2 will always be 0. When we add two odd numbers, the sum is always even, right? And when we take the mod with 2 of any even number, it is always going to be 0. So the thing is, there is one condition in which we can produce this 0 output when all are odd. That is, when all elements in my array or in my subsequence, I would say, are odd numbers. Or I can say all are even. That's one more condition. In both these two conditions, the output will be 0. The output will never be 0 apart from these two conditions, and that is because if we have odd and even both numbers in my array, for example, this one, this is one of the array, this is one of the subsequence we produced for this particular input. In this we have odd numbers 1, 1, 1, and we have even numbers 2, 2, 2. Now if we have odd numbers and even number both, then the output, this particular formula, will never produce an output as 0. It will always be 1, right? That's because if we have even plus odd concept, if we have one even number, one odd number, and then we take the mod with 2, this will always be 1, because this particular value will always be odd, and when an odd number is taken a mod with 2, it will always be 1, right? So the thing is, you will have to understand there are two conditions in which we can produce the output as 0 for my subsequence. That is, when I say output, it is this particular formula I'm talking about. That is, take the sum of the two alternate number and take the mod with 2. So there are just two conditions in which I can produce the output as 0 when all are odd numbers, because when all are odd, then every two alternate elements when added will be even, right? And even mod 2 will always be 0. And when all are even, let us say 2, 4, 6, 8, 10, this is the subsequence we have, then every two elements when added will always be even, right? So basically what I am saying is odd plus odd will be even, right? And even plus even will be even, right? We can produce the output as 0 only when this particular part is even, right? And this particular part is going to be even when odd plus odd is there or even plus even is there. We are adding every two alternate elements, right? So every two alternate elements has to be either odd or even. They cannot be a mix of odd and even as we have in this particular example. If they are a mix of odd and even, the formula is going to produce the output as 1 and not 0, right? Now the thing is, guys, you might have a question that even if it is odd and even, what if the sequence is 1, 1, 1, 2, 2, 2, right? It has odd, it has even. So the thing is, this particular subsequence is not valid, and that's because these two numbers are odd. So when they are added, it will be even, and the formula will produce the output as 0. These two numbers will also produce the output as 0, but these two numbers are going to produce the output as 1, right? So this particular subsequence is not even valid because in this subsequence, the two alternate elements are not producing the same output. Some are producing 0, some are producing 1, then they are producing 0, right? So it is not valid. We need a subsequence in which every two consecutive elements, when added and then taking the mod with 2, has to produce the same output. I told you guys that the output is going to be 0 if every two alternate elements are either odd, so all the elements in my subsequence should be odd, or every two consecutive elements are even, so all the elements in my subsequence has to be even number. And the third condition is for this particular case that every alternate elements are odd and even, or even and odd. That is, this is a valid subsequence because every two elements are odd even. They are alternate. They are not the same. They are alternate, right? It is starting with odd, so the next element is even. Now this is even, so this is odd. This is odd, so this is even, right? So every two alternate elements, so every two consecutive elements are even and odd, right? So when we say even plus odd, it will always be odd, and odd mod 2 is always equal to 1. So that is for this particular condition. So this formula is producing the output as 1 for each two consecutive elements in my subsequence. So I basically now need to find that how many odd elements do I have in my array, how many even elements do I have in my array. So let us say I have an array of 10 elements and 4 are odd and 6 are even, right? If we have 4 odd numbers, I can say I have a subsequence in which all are odd. I have 4 element subsequence, but I have 6 element subsequence and they are even, right? So I can create a subsequence of 6 elements in which all elements are going to be even, and the formula is going to produce the output as 0 for all the two consecutive elements. And there is one more condition, that from these 10 numbers I can create a subsequence of alternating even and odd numbers, that is even odd, even odd, even odd, even odd, or maybe odd even, odd even, odd even, odd even. This subsequence will produce the output as 1, right? I need to find the length of all possible subsequence, all odd numbers, all even numbers, all alternating even and odd numbers, and we need to see who has the highest length, because all those subsequences are going to be valid. Either the output is going to be 0 or the output is going to be 1, right? So now let me take you back to the code editor, and now let's solve the particular problem using the approach we have just found. So let me go to the code editor, and first of all let us count the number of even numbers we have in our array and the odd numbers. So I can say even is equal to 0, odd is equal to 0, and now let's run a loop for n in nums. I can say if n mod 2 is equal to 0, then we can say even plus equal to 1, else we can say odd plus equal to 1. So now we have the calculation of how many even number we have, how many odd number we have. All even numbers can form a subsequence, all odd numbers can form a subsequence, for which this particular formula what's given in the problem is going to produce the output as 0. All are valid subsequence, but there is one more possibility. Either the subsequence can be even comma even comma odd combination, or odd comma odd comma even. So our alternating subsequence can start with even or can start with odd. We are going to find for both the conditions. So let us find the length of the subsequence which starts with odd number and the numbers are odd, even, right? So I can say odd start is equal to 0. Let me take a flag which is as of now equal to true. I will tell you the use of this flag. For now, for n in nums, let's again run a loop in nums. If n mod 2 is equal to flag, that is, if my number is odd, if I got an odd number, then what I can do is I can say odd start plus equal to 1, that is I got my odd number. Now next I will search for an even number in my sequence, right? Basically I want odd even sequence. So I got my odd number because this flag is true, so the value will be taken as 1 for this condition. So we got our odd number. Let's now next find the even number. So I can say flag is equal to not flag, set the flag as false. So next time this formula is going to be true when this number is even, and when again the number is even, we are going to increase the size of odd start and we are going to say flag will be true. So this particular formula, this particular logic is going to find out the sequence for which the numbers are starting from odd, then the next number is even, then again it is odd, then next number is even, basically the alternating subsequence. And in this subsequence, this formula is going to produce the output as 1. Let us just copy this complete code one more time, and that's because we might need to find the subsequence which is starting with even and the next number is odd. So I am trying to find out a sequence which is starting with even. So I would say even start, and I will copy this even start here because I need to find for even, and the first number should be even, so I would set it as false. That's because if this is false, this condition is going to be true when the number is even. So now I have 4 different length: the number of even numbers I have in my array, the number of odd elements I have in my array, the number of elements I have in my subsequence such that it starts with odd, then it is even, odd, even, odd, even, and the number of elements we have in my array such that it starts with even, even, odd, even, odd. That's the subsequence we have. So we have even, odd, odd start, and even start. All these length are a valid subsequence length. We just need to return the maximum out of it. So I can say return max of these values, and that is going to be the answer. That is going to be the output for this particular problem. You can see the sample test cases are fine. I can submit this and all the test cases are going to be passed. So yes, we can see the runtime is pretty good. The memory used is pretty good. So we have solved this particular problem, and we have solved it in a very efficient manner. Although I can try to reduce the length of the code, but I deliberately wanted to keep this code in such a way that you are able to understand. Although I could have just used a single loop for all these conditions, I wanted that you guys understand that what we are doing. And that is why the odd start logic and the even start logic, I have separated those so that you can understand what's happening behind the scene. So that's it for this video, guys. If this video helps you to understand the problem, the solution approach, and the thought process behind the solution, then make sure that you hit that like button. And if you have not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. Thank you for watching this video, guys.